real representations of HDMA. So where you have a individual space that will be allotted, so respect to the particular channel. So here the space will be divided. Okay. So the what channel, okay, in a particular channel, what space need to be chosen. So that would be completely taken care by the broadcaster. Okay. And coming to the second one, it is something related with the frequency division multiple access. So how well the media will be divided, subdivided. So that would be the focus. So if you see here, you have a frequency bands which are separated according to the channel. So to each channel, each a specific frequency band will be allocated. See, if you remember in our very initial unit, when we discussing mobile computing initial topics, we have gone with a GSM. For a GSM, we used to tell that there is a frequency band which was allocated. So that means that the channel allocation, okay, there, okay, total there are 128 channels or so. For each channel, it would be some kbps. Okay, you have some band which was fixed for each of the channel. So that was completely okay. It can be taken as an example for your FDMA. And if you go for a further, so your channel will be allocated based on a time slot. So if it is based on a time slot, then you have a time division multiple access, time division medium access. So here, so synchronization can be done by using fixed allocation schema or dynamic allocation schema. So whether a particular time slot will be allocated according, okay, which was already fixed, or will it be dynamic. Okay. So whether how well a channel will be allocated to the specific user. Okay, what was a channel that need to be allocated to a particular signal that has been generated. Okay, that would be completely, it can be like fixed or it can be a dynamic allocation. So the schemes which are available are fixed and dynamic. So and coming to the next one, so there is some more modifications to these uh, for the channel allocation. So they have gone with some new technologies which are adopted. So especially the problem is with the collision detection. Okay, so initially the Aloha, how well a particular slot will be selected. Okay, and and there was no focus on the user who you are choosing. So there is no coordination among the users. See, because we have a multiple connections that need to be established. So which user, okay, to whom a particular channel has to be allocated, okay, at what time it has to be allocated, it was completely dynamic. Okay, so collision detection is not available. Okay, more here, they see, for example, sender A, sender B, sender C. So they are sending some data, okay, with a specific time slots. So they have certain data, voice or some data. So if you see to the particular time slot, there is a combination, there is a collision. Okay, see, at a particular timestamp, sender B and sender C data would be coinciding. Okay, they would be colliding. And if you see, there is another collision which was occurred here. Okay, so that was sender A and a sender C. So that means that there should not be any overlap. They should not have any interferences in between. So when I'm sending the data, the channel should be free. Okay, if I send another information at the same time, then there would be a collision. So initially, you need to sense this collision. So you need to listen whether it is a free or not. Okay, that's why you have a carrier sense multiple access. Okay, right. So that is that a carrier send or a signal need to be sensed. So whether it is a free to send or not, okay, that has to be ensured. So whereas in classical Aloha, if you see, there is no collision detection. So that means you doesn't sense any carrier signal. So whether it is free or not free, you directly send the data. So that's why you doesn't have any central arbiter. That means you doesn't have any control on the access. So okay, if you have any control on this axis, which means that you should able to detect this collision. So well, as we doesn't have any collision detection here, you doesn't have any control access on the media. So if the data gets destroyed due to collision, data retransmission is not supported. So whereas if you choose a classical Aloha, there is no possibility of data retransmission during the collision. So once you are sending, so what happens now? You would send some data. So let us suppose that there are few people who are interacting. Okay, I will send the data. I need to ensure that whether you have seen my data or not, right? So in a WhatsApp, I would send some message to you. So I need to ensure that all the person, okay, to a particular person, okay, whether he has received or not, I need to check, right? So if he did not receive it, even I need to say because of some collision, if some data hasn't reached the destination, so here the possibility is that your packet of data would be lost. So that means that I need to resend the data. So there is a chance, okay, you should resend the data. But whereas in a classical Aloha, you doesn't have that facility. You cannot resend or retransmit the data. So maximum throughput, okay, when you go for a particular GSM, okay, so he is telling that maximum throughput is 18%. And it works well light load. So that means that you should have a very light load, okay, especially if you have a lot of heavy traffic, okay, then your classical Aloha may not work. Why? Because there is a chance of lot of collisions. And moreover, you doesn't have data retransmission facility. So this is a classical Aloha. So you have some modified version of classical Aloha. Okay, you have certain small changes to this classical Aloha to make a slotted Aloha. Okay, so here the thing is that slotted Aloha, the name itself indicates that there are some slots. So the slots here might be a time slots. Okay, so as you have some time slots which are allocated to this classical Aloha, okay, at a particular time band, you need to send the data. So because of this, it was named as slotted Aloha. So in this case, all senders have to be synchronized. Okay, each transmission can only start at the beginning of the time slots. So that means that you should have, okay, when you are sending any data, what is the time slot which was allocated to the sender? According to the time slot, you need to initiate the process of sending the data, right? So thus making the sender synchronized. So here the thing is that all the senders will be synchronized. So that means that, so whenever you have a time slot, then only you can send the data. If you doesn't have any time slot which was not allotted, then you will be in a waiting start. So everything will be in a synchronized way. Okay, that means when there is a request to send the information, then it will be open. So as pictorial representations for classical Aloha as slotted Aloha are given here. Okay, even so there is only a change with a time slot. So it doesn't overcome any collisions. The collision still persist. But according to the slime slot, the sender will start sending the data. See, sender B, sender C are sending as per the time slot. Okay, and also sender A and C are okay, is sending as per the time slot. So this has been initiated before the time slot. So he has just divided the above same diagram in the form of time slots. That's it. So it doesn't overcome any issues. Okay. So only the thing is that they just introduce the concept of time slots. So it doesn't give any benefit for more than the classical Aloha. The drawbacks still persist in the same way. So here comes the next technology, that is carrier sense multiple access. So here in a media, the problem is that without sensing whether a media is available or not, you need to sense it first. And again, if you send the data, then there is no chance of having a collision. So the collision can be overcome when you sense the carrier. So whether a carrier is free or not, that need to be sensed. So one improvement to the basic Aloha is sensing the carrier before accessing the media. Okay, that means that is free or not, you need to sense it. Of CSMA exist. So you have non-persistent CSMA, P persistent CSMA and one persistent CSMA. So there are very little changes. Okay. So these points are already just discussed here. Okay, with a simple line. So it would be very easier, right? No need to go for an entire textbook and read 10, okay, what we call, you have a multiple lines. So all the information may not be given within 2 or 3 lines, okay, in a textbook. So you have a lot of some other information which was already known. So it was mitigated. You can have a look of CSMA. Station sends the carrier and start sending immediately if the medium is ideal. So that was a very general known thing. Okay, in classical, okay, when you introduce this carrier sense, it means that whenever a medium is free, then you can send the data. Okay, so you need to sense the carrier first. If the medium is busy, so if a medium is busy, what you need to do, you need to wait. So the station pauses a random amount of time, so it would be in a waiting state until it senses the medium. Okay, so that's how repeatedly you will be sending some what we call that ideal. You will be sensing the carrier. So how many times? Okay, you need to wait until it is free. If it is free, then again you can send the data. So when a media is busy, you need to take a pause. That means it will be in a waiting state for a period of time and sensing the medium. So in P persistent, so it is non-persistent. And if you go for a P persistent, system nodes also sense the media. Okay, so your system nodes. So here the stations are sensing the carrier, and also the nodes which are existing in the media, even they can sense. So, but only transmit with a probability of P. So you need to transmit the data with some probability calculation. So probability would be involved here. So with the station differing to the next slot with a probability of 1 minus P. So that is access is slotted in addition. So the thing is that you need to send data with P probability first. Okay, that means that you would be some 99 accurate that the data will be sent. And again, you need to send the data with 1 minus P probability. Okay, so if you add this to the CSMA, then it will become a P persistent. So non-persistent, you will sense the signal, sense the carrier, and then start sending the data when medium is free. If it is busy, then you will be in a waiting state and you would wait. When it is free, then it can ready to send. Coming to the P persistent, to the above information, you just add some probability transmission that I can transmit the data with a probability of P. Okay, during the next deferment, that is when again if you have a chance to resend, then you need to send the data with 1 minus P probability. Okay, so if you go for one persistent, all stations wishing to transmit access the media at the same time as soon as it becomes idle. So that means, so to the all stations, it's a kind of a broadcasting. To all the stations, you will transmit the access. So all the media will be open for all the stations. Okay, when a particular channel is idle. Right. So you would send the signal. If it is idle, all the other stations will be activating, and any of the station can use this particular channel. So this will cause many collisions if many stations wish to send and block each other. So what happens? So you have a single channel which was open for multiple stations at a time. So that means there would be a chance of many collisions. So here your carrier media would be only one for us. So that medium is accessible. If a particular media is sensed and it is open for all, then it will become a one persistent. Okay, so it's about a CSMA. So, and coming to the next one, demand assigned multiple access. So demand assigned multiple access. So it has added some new thing here. So the general improvement of Aloha access systems can also be achieved by reservation mechanism. So they just added some reservation mechanisms in demand assigned multiple access and combinations with some TDM patterns. So it's a completely a time division maxing access. So with some reservation which was included in between. So you have the same Aloha process only. So okay, how these time division multiplexing will be utilized and how these reservations were taken care. So that would be the focus in DAMA, that is demand assigned multiple access. So these schemes typically have a reservation period followed by the transmission period. So okay, you have some reservation followed with the transmission period. So during the reservation period, stations can reserve the future slots in the in the transmission period. So that means that you, let us suppose that you have a particular transmissive data. So for the okay, what was the transmission period and what is the reservation period? So these two fields has to be specified. So while depending on the schema, collision may occur during the reservation period. So the transmission period can then be accessed without collision. So during the reservation period, they are checking if there is any collision during the reservation period, then it can be transmitted okay without the collision in a transmission period. So what happens, you have a reservation period time step and also you have transmission period. So if there is a collision, then you need to wait for okay, when there is a reservation, that it ensures that you doesn't have the same reservation to the other sender, right? So what happens at the time, you doesn't have any collision that should occur. So when you choose a reservation, so what happened ma? So initially what is the case? Mm, so you have a classical Aloha with lot of collisions without any coordination. So you doesn't have any time slots. And if you go for a slotted Aloha, there is a timestamp which was embedded over there. Okay, so to the same, so there is a chance of collisions again. So here, okay, to avoid a collision, they have gone with some new technology that carrier need to sense. Okay, you need to access the media and sense whether there is any traffic or not. Okay, that is a carrier sense. So what is the next upgradation? Even with the carrier sense, there is a chance of having the collisions. See, if you see a non-persistent, it doesn't have any problem. If you go for a P persistent, you are sending with probability of P, okay, so that you doesn't have any collision. And also you are sending with 1 minus P, okay, if there is a chance of having a collision, you would think. And if you go for one persistent, so definitely you have a collisions. So how to overcome these collisions again? So go with some reservation mechanism. So what is a new technology that has been upgraded? You have DAMA. With a DAMA, with some reservation mechanism, we are avoiding the entire collisions. So you should reserve. Okay, a sender should go with some reservation. Okay, so that means that to the particular transmission period without any collision, you could send if you have some reservation. Okay, so one basic scheme is demand assigned multiple access. So he just gone with the same introduction. Okay, also called as reservation Aloha. Okay, a schema typical for satellite systems. So in a satellite systems, okay, they would go with this DAMA or reservation Aloha. So Dama, whether it was given in a diagram, let's have a look. So it was a okay demand. So it's a demand based multiple access. So you have some reservation which was allotted. Okay, as per the reservation, you need to. So if you go with a generic Aloha, so there is a chance of collisions. So he depicted some collisions here. Okay, so it was not clearly given. So he was just posing that there were some problems when you are choosing an Aloha. Okay, so that means he just mitigated the above diagram, I think. Okay, this diagram, he just combined for all the senders, and he just parallelly compared. Okay, Abhishek, what are you doing, ma, on the screen? Mm. So it is something data which was sent with some senders. Okay, sender A, sender B, sender C. Okay, and it is the with a reservation. So if there is any reservation, there is low chance of having a collision. So you just have a depicted diagram in a way that during the aloha there is some collision. So at the same time step, there is another user that would be sending the same data. Okay, so here he was on the same one. If you are overriding with another block, you just say that there is some collision. Okay, so you have a different shades, right? With a dark shade, he has gone with another diagram, another block which was drawn on the same pattern. So that means that you should specify that it's a collision over there. So in Alohas, you have a major problem. If you go for a reserved, there is low chance of having a collision, because when there is a reservation, so there is no chance of having a collision. So you need to depict that with a diagram. So it would be somewhat repetitive. You can okay, Dama. So he has given some two modes, it seems. During the contention phase, follow the slotted aloha scheme. All stations can try to reserve future slots. So during this slotted aloha scheme, all stations are trying for reservation. Okay, so so it was actually the diagram what we have seen. So they are going for some reservation bookings, it seems. Collisions during the reservation phase do not destroy the data transmission, but only the short request for data transmission. If successful, a time slot in the future is reserved and no other station is allowed to transmit during this slot. So this was a general thing what we know already. So what happens if you go for a slotted aloha scheme? Okay, so you should apply for a slotted aloha with some reservation future slots for the stations. So when they go for this particular reservation access, so the reservation slots are already okay. According to their availability, they would reserve a particular time slot. So when you are transmitting the actual data, there is no chance of having some data destruction. That is, there was no chance of having the collision. So if this process of accessing the assigning the reservation so is successful, okay, our time slot in the future is reserved and no other station is allowed, means a particular time slot will not be given for some other person and it was reserved for the same station. That's it. So I think you understand with these DAMA, right? Demand assignment multiple access. Now you have some more modifications to the DAMA. Then you have PRMA, that is packet reservation multiple access. So you okay. So it's a kind of some implicit reservation, it seems. So a certain number of slots form a frame. Okay, here a certain number of slots will become a frame. Frames are repeated. So that means how a packet will be made. So packet with certain number of frames which are integrated. So he just added some data frames which are integrated to form a packet. So from the same kind of idea, okay, he just divided these individual time slots to make up a frame. So here frames are repeated. So you are using the same frame set, okay, according to the availability. Okay, what is the reservation you have chosen? A particular slot on the frame will be allocated. So stations compete for empty slots according to the slotted aloha principle. So when you are choosing any reservation, So if it is empty, then only you opt for reservation, right? Once a station reserves a slot successfully, this slot is uh, automatically assigned to this station in all following frames as long as station has data to send. So if a particular frame has been reserved, so okay, if a particular time slot has been taken, okay, then that would be reserved for all the state, or that would be reserved in all the frames first. So competition for this slot starts again as soon as the slot was empty in the last frame. Okay, so when there is any new requirement, okay, so when our data has been finished, okay, there is no way, no chance of sending the data, then that will become an empty slot. So you have a some set of series initially, you will go with some reservation, so there is some other substations which will go for a reservation, so that reservation slots will be filled, and the same will be repeated for all the frames first. So later, according to the unavailability and how well the data would be finished, so that slot will become an empty, okay, upon utilization. So that's a PRMA. So there is some gap, I understood that. So all the information was not given clearly, okay. Yes, just address that, okay, how a frame division will be there in a PRMA. So whereas if you go for a DAMA, you doesn't have any frames here. So when frames has been introduced, then it will become a PRMA, packet reservation multiple access, PRMA. So I think here you should have some difference should be given. It was included directly. So it's about a PRMA. Then comes the another technology, that is multiple access with collision avoidance. Okay. So CDMA, up to CDMA we should go. Okay, so how well different technologies came into picture. So what are the problems they just face? Okay, that are addressed. Multiple access with collision avoidance. So it uses short signaling packet for collision avoidance. Okay, so for this multiple access with collision avoidance, so internally for collision avoidance they send some packets. Okay, so the two packets which can be sent are RTS packet and CTS packet. So when okay, so when you want to send some data to any of the to some end user, then you need to send RTS packet first. Okay, before sending the actual data, initially you need to go with RTS. So how well? So in a computer networks, you already have seen this multiple access collision avoidance as well. Okay, so so what happens here to avoid this collision? So we are going with some small packets. So what these packets? One is RTS, request to send. So before sending actual data, I need to send a request to send. So when it is okay and a particular request has been granted, then a CTS signal will be sent. The receiver grants the right to send as soon as it ready to receive. Okay, so what happens when you send an RTS? So it will send you a packet with CTS. So it's something like carrier sensing. Okay, before sending the actual information, okay, you need to make the other user to be ready. Okay, so that readiness will be checked with RTS and CTS. So you need to send an RTS, then you would receive a CTS, that is clear to send. Okay, so when you receive this clear to send packet, you can send your actual data. So signaling packet, so if you send some any signaling packets, it consists of sender address, receiver address, and the packet size. So to whom you want to send the data and what is the sender address, so that means source IP, destination IP, and which is the packet size. So in the form of IP packet, right? You need to remember you should have that packet information. So that means you need a source IP and a destination IP. So he just overcome that as sender address and receiver address with some packet size. So that multiple access collision happens because multiple packets are